5 years later, John Weil at the University of Colorado in Denver studied people who were living at Leadville, 3,100 meters, or 10,000 feet in Leadville. In his small group, the blunting or lack of responses came on slowly with about 10 to 30 years of living at this high altitude. Not a very high altitude, actually, at 10,000 feet. There is a problem in measuring HVR, the hypoxic ventilatory response, and I'm going to tell you about it. In acute isocapnic hypoxia, when you keep PCO2 and PCO2 completely stable for 10, 20, 30 minutes, the ventilatory response begins to fall after about 5 minutes. By 20 minutes, it's usually lost about half of the peak response. This was first called hypoxic ventilatory depression. However, there really wasn't any loss of the brain's response to CO2, and we don't know what caused the depression, so it is now called hypoxic ventilatory decline. So it's still HVD, but with decline instead of depression. And we tested whether this might be due to endorphin in the brain. And the little red notch here is when we gave endorphin, blockers, Narcan, and it didn't cause any change in the response at that point. In 1974, Tony Rebuck and Moran Campbell at McMaster University in Hamilton, Ontario, reported that the rise of ventilation was a linear function of oxygen desaturation in isocapnia. This is a schema of what they found. A typical hypoxic ventilatory response is a rise of 1 liter ventilation per minute for each 1% desaturation. That's this line that's called isocapnic. So as saturation goes down, the ventilation goes up in a linear fashion. That makes it so much easier to measure the response to hypoxia because it only requires a single hypoxic point on that curve. Usually that's done at about a saturation of about 80%. You have to keep the PCO2 constant. If you don't keep the PCO2 constant, you get what is called poikilocapnia. That's similar to going to altitude because the response only goes up a little bit as the PCO2 goes down, blocking the hypoxic sensitivity.